Let's start talking about iterated integration. This is section 14.1 in the book. Suppose that we want to integrate over a certain region in the plane, which is bounded below by some curve y equals, let's say, g sub 1 of x, and above by another curve, y equals g2 of x, and it lies above some interval from a to b on the x-axis. So this is going to be my region R in here. We call a region like this vertically simple because if we draw any vertical line through this region, it always enters on this bottom curve G1, and it always exits on the curve G2. So entering on G1, exiting on G2. The way that this can be described in integrals is on the inside, we'll be integrating some function f of x and y as y goes from g1 of x to g2 of x, and the outside integral will represent that x is going from a to b. So one thing to notice is that when I write an iterated integral in this form, on the outside, my dx's, I give my bounds, and those are both numbers. On the inside integral, having to do with y, my bounds are the curves that represent the bottom and the top of the region. Here's a typical example. Let's say that we're integrating x goes from 1 to 2, y goes from 2x to x plus 1, 24xy dy dx. The way that you evaluate an integral like this is you start off by carrying out the integral which is on the inside. So when I integrate with respect to y, I'm going to treat all the x's as constants. So the integral of 24xy is going to be 24x times 1/2 y squared. Let me go ahead and simplify that a little bit and just make that 12 xy squared, where y is going to start at 2x and end at 2x plus 1. So as usual, we'll plug in the two endpoints and subtract. So I'll have the integral from x equals 1 to x equals 2. First of all, I'm going to substitute y equals 2x plus 1 in for the y here. So it'll be 12x times 2x plus 1 squared minus, and then I plug in y equals 2x. 12x times 2x squared. Notice that once I've substituted in, I end up with an integral that only involves x's. So let's simplify that a little bit before I carry out my second integration. So distributing here, I'll have 12x times 4x squared plus 4x plus 1 minus 12x times 4x squared and distributing some more, I have 48x cubed plus 48x squared plus 12x minus 48x cubed dx. And notice that the 48x cubes cancel out. So my inside integral, my outside integral from 1 to 2 is of 48x squared plus 12x. And now we carry out that integral with respect to x. The integral of 48x cubed, or x squared, is going to be 48 over 3, or 16x cubed, plus the integral of 12x is 12x squared over 2, so 6x squared. And this goes from x equals 1 to x equals 2. Plugging in the endpoints and subtracting, I have 16 times 8 plus 6 times 4 minus 16 times 1 plus 6 times 1, which is 16 times 7 plus 6 times 3. Oh, just checking to make sure that was right. It's 42, carry the 1, 112 plus 18 is 130. Now, one note on notation. Generally, when the bounds are given, the y equals and x equals are not explicitly written. So you'll typically see something that looks like the integral from a to b, integral from g1 of x to g2 of x. And you'll rely on the context to know that it's x going from a to b on the outside, and y going from g1 of x to g2 of x on the inside.